Hello guys, welcome to Tithya Girl. Today I'm going to explain to you guys how to calculate the general equation of a tangent line to our function in a specific point. Now there's some prior knowledge required for this video, such as derivatives and point slope formula. So if you don't know what that is, I'll leave a link down below to those videos so you guys can watch them before this one. And let's jump into the video. So in the previous video, I explained to you guys the concept of derivative and how to calculate it through the limits and the difference quotient equation. I'll leave a link down below in case you want to check it out first. I mean, you should check it out first. But as you already know, the derivative only tells us the slope of the tangent line, but the general equation of a linear function, apart from the slope, also has the y-intercept. So we keep y and x as variables, but apart from the slope, we also need to calculate the y-intercept. And that's what we're going to do today. We're going to calculate the entire general equation of the tangent line in our function in one point. Now we're going to follow the same steps that we use to calculate the general equation of a linear function from 2 points. I'll also leave the link down below to that video so you can check it out first. But basically this is like a little summary of that video. When we have to calculate the general equation of a linear function from 2 points, we first calculate the slope through the difference quotient equation, and then we calculate the entire general equation with the point slope formula. So first we're going to calculate the derivative of our function. Let's say our function is, so let's say we're going to use this function, and to be able to calculate its derivative through the limits equation, we are also going to need the value of our function in x plus h. Now I'm going to go through this quickly, so if you want to check what I'm actually writing down, maybe you should just stop the video. Now we're left with this expression, and because h tends to 0, h is very close to 0, we can actually assume that h is 0, and then this would cancel, and we would be left with our derivative is actually 2x plus 3. Alright, so the first step is done. I'm going to write it down here. Now, as I said, the derivative, the slope of the tangent line, changes in each single point of our function. It's the same expression, but the value is different. So it depends what value of x we're gonna calculate it in. The final value is gonna be different. Let's say we have to calculate the general equation of our tangent line in x equals a. Now, we're going to use the point slope formula, but we're gonna write it down in a different way. So in this case, we got y. Now we're gonna keep y and x as variables as always. And in this case, in the point slope formula, we use the coordinates of one point. And in this case, we're gonna do the same. We're going to use the coordinates of one point, that is x equals a. And the value for when x equals a in our function is f of a. So the coordinates of the point that we're going to use to calculate our formula in is going to be a f of a. Those are going to be the coordinates of our point. So just continuing, y minus the y value for our point is going to be f of a equals m, which is the slope, We already calculated the slope, which is this one, but it's the slope in that point, so when x equals a. So it's going to be the derivative and a and then we're going to multiply by x minus the x coordinate of our point, which is a. So that's it. This is the equation that we're going to use to calculate the entire general equation of our tangent line in a specific point. Now, this is the general equation. Let's say that this is an actual exercise and they're asking us to calculate the general equation of the tangent line in a specific point of our function. Our function was f of x was x squared plus 3x. So now that we got this equation to calculate the general equation of the tangent line to our function in a specific point, let's say that they're asking us to calculate the tangent line to this function in x equals 2. Let's just, first we need to calculate the value of our function when x is 2. So we're just going to substitute. So that's 10. Then we have to calculate the value of our derivative when x is 2. So the slope of the tangent line when x is 2. And then we're just going to substitute in here. And that's it. We're just going to substitute in this equation. Now I'm just going to play with the numbers to make it look like this and have the slope and the y-intercept separated. This would be the general equation of our tangent line in this function when x equals 2. So if this video gave you a little hint of how fun derivatives can actually be, please give it a thumbs up, comment down below, share and subscribe.